In this video, we're going to look at a very difficult question relating to discriminants. So it tells you a curve with this equation in the form of pretty much a quadratic does not intersect with this line here. So how does that relate to a discriminant? Well, first of all, what the discriminant is, just a quick reminder. When a quadratic is written in the form ax squared plus bx plus c equals 0, where a is the coefficient of x squared, b is the coefficient of x, and c is the number at the end, the discriminant is b squared minus 4ac, and there's three options for it. It could either be greater than 0, it can be equal to 0, or it can be less than 0. So let's write those out. Now, what does it mean in each instance? Well, when it's greater than 0, that means that a quadratic has two solutions. When it's equal to 0, that means that a quadratic has one solution, whereas when it's less than 0, that means that a quadratic has 0 solutions. So what we can do here is make the curve here px squared minus 4px minus 5p equal to the equation of the line 2x minus 12. We can then bring everything to one side to make one side equal 0. In this case, it makes sense to take away 2x and add 12 to both sides. So we get px squared minus 4px. And I'm going to join the minus 2x term onto this, just so you can join the x terms later, together later on. We have minus 5p already on the left-hand side, which is a constant because p is a constant. And then plus 12, all equals 0. Now, in order to bring it to this format here, we need to realize that, well, there's two x terms here. What you can do to negate that is you can factor out x from both of the terms. In this case, to go from x to minus 4px, you multiply by minus 4p, and to go from x to minus 2x, you multiply by minus 2. And then you're left with minus 5p plus 12, all equals 0. From here, you can get values of a, which is p, b, which is minus 4p minus 2, and c, which is this term at the end. But why did I do all that? Well, it's because it tells you that they don't intersect. That means that when you put them equal to each other, the quadratic that you get has 0 solutions. What does that mean in terms of the discriminant? It means that the discriminant is less than 0 because there's 0 solutions to this quadratic. After taking values of a, which is p, b, which is minus 4p minus 2, and c, which is this constant at the end, minus 5p plus 12, we can substitute them into this inequality, b squared minus 4ac is less than 0. So let's do that. I'm going to do that here actually. So we have b squared, which is minus 4p minus 2, all squared, minus 4 lots of a, which is equal to p, multiplied by c, which is equal to minus 5p plus 12. And then we can make it less than 0. Now, when you square a bracket, that's the same as just multiplying it by itself. So let's write it out twice. Okay, and yeah, let's focus on expanding this out. Minus 4p multiplied by minus 4p is 16p squared. Minus 4p times minus 2 is plus 8p. Minus 2 times minus 4p is another plus 8p. So they actually combine to give you plus 16p. Minus 2 times minus 2 is positive 4. And then here, let's be a little bit careful. Minus 4p multiplied by minus 5p is plus 20p squared. Minus 4p multiplied by 12 is minus 48p, is all less than 0. You might have already realized that we now have to collect some more like terms because there's 2p squared terms. Those add to give 36p squared. There's also two terms with p involved. 16p minus 48p is minus 32p, plus the 4 is all less than 0. Let's now compare it to what we need to get to. So from a quick comparison, it's clear that every term that we currently have is a multiple of 4. And if we do divide each term that we have by 4, we actually get to this expression here. So let's do that. Dividing each term by 4. 36p squared divided by 4 is 9p squared. Minus 32p divided by 4 is minus 8p. And then plus 1 is all less than 0. Great, that's everything for part A of the question. Let's now move on to part B. So with this quadratic inequality, what you want to focus on is first solving this quadratic. So I like to do that using the AC method. So I'm just going to very quickly do that. Now, why do we solve it and how does that help us find the actual inequality? I'll go through that. So straight off the bat, if you use the AC method, 9 times minus 1 is 9. Are there two factors of 9 that add to give minus 8? There actually isn't. Although it seems like minus 9 and 1 would work because that adds to give minus 8, that actually multiplies to give minus 9, which we don't want. Yep. So that means that we actually have to use the quadratic formula. So I'm just going to write that out. Minus b plus or minus square root of b squared minus 4ac all over 2a. Now, a is of course just equal to 9, b is equal to minus 8, and c is equal to 1. Putting that into this formula, we have minus b is 8. I'm sure you guys know how to use the quadratic formula. I'm just going to quickly put it in. I like to put everything in brackets, so like the value of b, which is minus 8 all squared, minus even 4ac. I like to put 4 in a bracket, and then a, which is 9, multiplied by c, which is 1, all divided by 2 lots of a, which is 18, because 2 times 9 is 18. I'm going to do this very quickly on my calculator. 8 minus square root of, sorry, spare me one moment, minus square root of minus 8 all squared. You guys can skip ahead if you like. It's 4ac all over 2a. One solution is 0.15. I'm just going to write in decimal format. And the other solution, when you use a plus instead of a minus, is actually 0.74. So why did we solve it when we want to find the inequality? It's because if we draw a very brief quadratic representing this, we know that it crosses at 0.15 and 0.74. So let's very briefly draw that out. It'll look something like that. What we're interested in is where the quadratic is less than 0. Now, where is it less than 0? It's where the quadratic is negative in terms of y values, and that's below the x-axis. So that's in between 0.15 and 0.74. So we can say that when the p-value is greater than 0.15 but less than 0.74, that's when the quadratic is below the x-axis, and that's when the quadratic is negative. And therefore, that's the set of possible p-value, for this question. Quite a lot there, but hopefully that makes sense. And if you enjoyed the video, please leave a like and subscribe. I'd appreciate it a lot. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.